G'day, that's the chatter pattern on the end of a tool handle. This is a tool handle for my limited edition negative rake scrapers. This is the second batch I've done. The last batch sold out very quickly. Thank you to everyone that's bought them. I can't believe how many from the US have bought these. It is quite an expense to send things up to the United States from Australia. Unfortunately, it costs a lot of money. I don't get any of that money. It all goes to Australia Post and whatever other postal services are involved. But look, yes, I can't say it enough. I do appreciate all the support from my good friends in America. You are easily the biggest supporters of me. 75% of my audience is from the US. And a lot of you are helping me out by getting online and buying stuff through my shop. Very, very much appreciated. This video is for Jeff Fish in WA. Jeff, you asked me about my pressure chambers and my vacuum chambers. I know that there's a lot of interest in resin out there. So this is all about, yes, my vacuum chamber and my pressure chamber. Now, as a lot of you know, I deal a lot with epoxy resin and wood, but also with gum nuts. And especially because of the gum nuts that have got a lot of seed chambers, a lot of cavities to them, I really do need to rely on both a vacuum chamber and a pressure chamber. So I found that both of these have helped me considerably reduce not only the cavities, the air cavities or the air locks, but also the bubbles that might otherwise be formed or appear in the resin. One thing I also do is I work with a lot of resin, so I might be mixing up a 1.5 kilograms or even 2 kilograms, that's about 2 litres of resin at a time, and I haven't got the time to carefully stir it so that I don't mix in any air bubbles. I do it quickly, lots of air bubbles get mixed in, but I know that I can rely on both the vacuum and the pressure to get rid of those bubbles. I rely particularly on the pressure chamber to force a lot of the resin into the cavities or the seed chambers of the gum nuts, and I use the vacuum chamber also to make sure I can suck a lot of the air out of the pores of the timber so that the resin can flow in there, and once again there's no fine bubbles left around the timber that I might be working with. Vacuum chambers, let's have a look at vacuum chambers. Vacuum chambers are a lot easier to make. DIY vacuum chambers are a lot easier than pressure chambers. Pressure chambers are a completely different kettle of fish, and I'll talk about those in a sec. But let's have a look at the vacuum chamber. Now you can see with mine I've made it out of a very large section of PVC pipe. The internal diameter is something like, well, it's 360 millimeters, which equates to about 14 inches. So it's a very big diameter, but also I've got the volume, or the depth I should say, and I've got a good 2 feet of depth there. This was one of my earlier models of vacuum chamber, which I did use quite a lot, but it just simply didn't have the capacity that I needed, so I made a bigger one. But this is a good one to show you how I did make this. Once again, as I mentioned before, just a section of PVC pipe. This has got quite a thick wall. There it is there. It'd be almost, well, perhaps 8 millimeters. On the bottom, it's just a piece of timber that has been turned with a flange on it to slot it inside the diameter of the pipe, and it's siliconed in. So it's simply sealed with some silicone. I probably also made sure that I did seal the inside, the other surface of this timber, so that no air actually was sucked through the pores of the timber, which could be an issue. Now here is my lid. Not in the best shape now, but this was see-through perspex. It's got a lot of resin and dust and all sorts of other stuff all over it, but that was a window through to the inside of my vacuum chamber. That hole there is simply the inlet for the hose to suck the air out. This is just timber. Once again, probably have sealed it to make sure that the air doesn't get sucked through the pores. The perspex is on top, and siliconed in place and also screwed, and it's on top so that the force forces applied to it are downwards and are basically making the seal between the perspex and the timber even tighter. The same is the case with the rim around here, or the flange around here, which gets put onto my lid, and onto the rest of the vacuum chamber, and then when you put the vacuum on, everything is sucked down. I have put some silicon around here, once again, so that it acts as a seal. It's like an O-ring. So that's how my vacuum chambers work, and this is simply a bigger version of it. The windows are very important. You are looking inside your vacuum chamber so that you can see what's going on, and you'll see the resin initially frothing as all the air gets sucked out of the wood or from the air trapped in the cavities of the seed pods. And when you see all of that bubbling dissipate, that's when you know you can actually turn the vacuum off. Now I've got my vacuum chamber hooked up to my vacuum pump, which is just under there. We'll get to that in a sec, via this rigid pipe here. Now remember, this pipe does need to be rigid. Don't fall into that trap of buying a flexible, non-rigid, non-reinforced pipe, because it will just collapse when you start putting any vacuum on there. I've got this ball valve here so that I can release the air, or when I'm putting the vacuum pump on, I close that off there like so. That is important. What you can't do with resin is release the vacuum suddenly. So just turning off the vacuum will cause a little bit of an explosion inside your vacuum chamber, and you'll end up with resin everywhere. So what I do is release the vacuum, the pressure in there, the negative pressure in there, slowly via that. So that valve there is quite important. And then we go to my pump, which is just underneath here, and your vacuum pump can be any sort of vacuum pump. I'm not sure what I've never used a vacuum cleaner as such, but there are vacuum pumps on the market that you can buy. This was actually out of a dairy, this being the motor here, the electric motor, and this being the pump over here, and it's as simple as that. So that's the vacuum chamber and the vacuum pump, and now let's have a look at the pressure chamber. Now this is my pressure chamber here. It was not quite a homemade thing. I certainly did none of the welding on this, and I am reluctant, I'm reluctant to actually talk about this, but I will. But remember that what I've done here, I'm not recommending to anyone. Pressure chambers are dangerous. If they're not done properly, things can go wrong. You can explode the lid off or whatever else. I put 40 psi of pressure in my vacuum chamber, so that's what it needs to hold or withstand. I've gone for this gas cylinder, and I did my calculations. I knew that the pressure that I was putting in here was far, far less than what this gas cylinder has been rated to. I have had professionally done this, whole thing was cut in half, so the gas cylinder was a lot taller. It was cut, and I've had a big flange put around here with these studs on here. I've got 12 studs on there. I only use 6 of those studs now. And here is my lid, the top of my gas cylinder. I have got some registration marks here so I know which stud line up with which holes. And there's my lid. I've got washers on there on the 6 studs that I need, and here are the nuts that I use to tighten it up. So I put those on, and then when I am tightening those, so they go on every second one, and when I'm tightening them up, I tighten them up gradually all the way around. I've got my line, my pressure line here to my regulator up here, out to the other room in the workshop where my compressor is. So when I'm ready to use this, I've got my work in here, I've got the studs tightened up, I turn this valve on, it allows the air in, and I've got another valve here which is also turned off. Once it's been taken up to pressure, I just leave it, and you might have just heard the compressor kick in, so it just kicks in as it needs to keep or maintain that constant pressure throughout the curing process. As I mentioned earlier on, my curing is usually just done overnight. Sometimes if I've poured the resin early in the morning, I can release the pressure later on in the afternoon. But I just tend to leave it overnight, come back the following day and release the pressure. Now I'm just going to take this lid off again and put it to one side because I wanted to show you my O-ring. There's my O-ring there, and it is not even joined. You can see that there's one end of it there and the other end is it over there. So it does overlap considerably. It's very, very simple. All I've done is I've siliconed that in place, and that acts very, very well as an O-ring. Now, we initially had a big rubber washer that went all the way around, and I just found that that didn't work nearly as well. It was just a bit too rigid, that inconsistency, whereas this O-ring is just a little bit more spongy, I suppose, and it can create that beautiful seal. So I've never had any problems with that O-ring system. I know that this is a bit of overkill for a lot of people because it is so big. I can get bowls up to 14 inches, 360mm diameter inside there. I can get several gum nut grinders in there. I can mould up, I think it's about 17 all up. So that's why I need that capacity. I can stack lots of bowls in there, get lots, because I've got lots of height in here to use, so I can get a lot of work here, and that's why I've got such a big pressure chamber. I know what a lot of people use is a pressure pot that's used in the painting industry, and they can be up to 10 litres big. Some of them are even, well, there's a lot that are even smaller than that, and they come in quite a reasonable price, and obviously they're made professionally, engineered professionally and all that sort of thing, so I can recommend those. They're worthwhile purchasing. I can't recommend this because I'd hate for people to make one of these themselves and then for things to go wrong, because as I said, if things go wrong with this, they can go wrong badly. Well, that's it. I hope you got something out of that. Look, I know that some of you will be a bit overwhelmed by the potential costs of those setups, but one thing I would like to say in finishing is, might sound like a broken record for me, but I often think that those sorts of purchases can be made by clubs. So if you are in a club, you might even suggest to your club that they invest some money in a pressure chamber or a vacuum chamber or both. I think that's the sort of thing that clubs can do, and I also know that there's a huge amount of interest in the combination of resin and wood, and I'm sure that a pressure chamber and a vacuum chamber in a club would get an awful lot of use. Well, I'll leave you with that thought. Make sure you keep turning safely in the meantime, and I hope to see you another time.